let's focus on this question which appeared in 2008 and 2015. Now, a lot of students, when they see this question, they are unsure that they can actually adopt the very familiar four-step method that we use to determine empirical formula of a compound. So many of them stumble at this question and they are not sure how to proceed. Now, when we deal with chemical calculations, very often we'll be given the mass of each element in the compound and then asked to determine the empirical formula of the compound. Now, one common example is shown over here. So chemical analysis shows that a compound contains 79.9% mass of carbon and 20.1% mass of hydrogen. So we are to calculate the empirical formula of this compound. So how we can determine the empirical formula is by determining the number of moles of carbon and hydrogen in this compound and then find the simplest ratio. This is a very common four-step table that we will always teach students to write to guide yourself in tackling this type of questions. So we are given the mass of element. For carbon will be 79.9. For hydrogen, that will be 20.1. AR of the element you can actually find in the periodic table. So this periodic table will be given to you in the exams. So we are interested in carbon. So what is the AR of carbon? Okay, carbon is over here. The AR, which is the relative atomic mass, is 12. You can just refer to the number below the chemical symbol to determine what is the relative atomic mass of each element. So carbon, it is 12. So over here, okay, we know that AR of carbon is 12. Now what about hydrogen? For hydrogen, the AR is 1. So AR of hydrogen will be 1. Now number of moles is determined by mass divided by the molar mass. For element itself, we can just use the mass divided by the AR. So that will be 79.9 divided by 12. Which gives me 6.6583. So this is not the final answer, so we'll leave it in 4 to 5 significant figures. Okay. Now what about hydrogen? The moles is 20.1 divided by 1, so 20.1 remains. So next, to determine mole ratio, what we can do is to use the value that we achieve in step 3 and use it to divide by the smallest value that we achieve in this particular step. Alright, so 6.65 as compared to 20.1, 6.65 is definitely a smaller value. So we will use all the values that we achieve in step 3, divide by the smallest value. Okay, smaller value now is 6.6583. So now I will use this particular value, divide by itself because this is a smaller value. Okay, and I will achieve 1. For hydrogen, I will use 20.1 divide by the smaller value, which is 6.6583. I will achieve 3.018. So for empirical formula, we know that the value must be a whole number. So let's round off 3.018 to 3, which is a whole number. So the empirical formula will be CH3, and of course we don't need to write the value 1 there. Not writing anything there is understood as 1. So using the same four-step method, we are going to determine the moles of Y in this compound. So in this question, they say that the formula of an oxide of element Y is Y2O3. Now Y2O3 is a compound that we're dealing with in this question. And the other info given to us is 8 grams of Y2O3 contains 5.6 grams of Y. So just from this info itself, we know that this whole compound, the mass is 8 grams. Okay, we have Y and we have O. Now Y, the mass is 5.6 grams. What about O? We can just use 8 minus 5.6 to determine the mass of oxygen in this compound. Okay, so just key in your calculator, we'll know that 8 minus 5.6 gives me a 2.4. Alright, so we can actually fill this mass in step 1. Alright, so mass of element Y, that will be 5.6 grams. Then for oxygen, that will be 2.4 grams. AR of element for Y, I don't know what element it is, so at this point I'm unable to fill this up. For oxygen, the AR of oxygen, if we refer back to periodic table, oxygen is over here. Okay, so the AR is actually 16. So let's fill that out. Okay, AR of oxygen is 16. Number of moles, Y, I don't know what is it. Okay, and that is what we are required to find in this question. Now, what about oxygen? To find the number of moles of oxygen, we'll use the mass of oxygen divided by the AR of oxygen. Okay, that will be 2.4 divided by 60. Okay, and if you look at the options in your answer, all the options are left in fractions. So I'll just leave the number of moles of oxygen as fraction. So what's the mole ratio? Based on the formula itself is Y2O3. So the mole ratio is a 2:3. So at this point, are we able to work out what is the number of moles of Y? So let me bring the table to the left. So from here we can see that the mole ratio between Y to O is 2:3. So number of moles of Y over the number of moles of O is 2:3. Now in this question we are focusing on the number of moles of Y, which means we want this numerator, right? So we need to make the number of moles of Y the subject. Okay, so what we can do is bring the denominator, number of moles of O, up to the other side of the equation. So number of moles of Y will be 2/3 multiplied by the number of moles of O. Now, do we know number of moles of O? Yes, we know. We actually work it out over here in the table. Okay, so number of moles of O is actually 2.4 divided by 16. So we can just plug this value into the equation. So number of moles of Y will be 2/3 multiply 2.4 divided by 16. So with that, we have already found the answer. Okay, so number of moles of Y is 2/3 multiplied by 2.4 divided by 16. So do we have this value in the options? Now let's take a look back at the question. And we have this option here. So A must be the correct answer. Now take note, as mentioned, this question is pretty special because most of the time we actually work downwards in sequence, okay? We find what is the value in step 1, then followed by step 2, step 3, then determine the mole ratio, which is in step 4. But this question is pretty special because if you realize, we don't even need the value of AR, we skip step 2 for element Y. Even so, we are able to determine what is the number of moles of Y because we are able to determine the values in the other steps, okay? And we kind of work backwards to determine what is the number of moles of Y. Now this question is quite interesting. For mole concept and chemical calculations, you are advised to expose yourself to different examples and practice different types of questions. Once in a while, interesting questions like this will appear. Once your concept is strong, you should be able to manage this type of interesting question. Now if you find this video useful, please like the video and subscribe to the channel. Don't forget to share with your friends. If you'd like to have more chemistry resources, you may want to check out my website. The link is in the description below. Have fun learning chemistry, and I will see you soon.